0% JavaScript and 100% Rails backend. So this is the auth lecture. Welcome. Stay with me. We have to have the lights on because this is going to be a lot. I would recommend that you don't eat something super heavy for lunch because the second half of this is also going to happen in the afternoon. And man, is it a doozy. Please stay with me. Ask questions. If I go too fast, stop me because this is for you, not for me. I've done auth before. I've probably done auth better. What I want to give you here is a sense of auth's scope, how the pieces fit together. Will you probably wind up referring back to this code, asking questions about it in the future? Absolutely, and you should. What I want you to walk out of this room with is not the ability to flawlessly execute the three-point turn of auth on command, because nobody can really do that, but figure out the why and the how at a high level of authorization with JWT tokens. A lot of this will be similar to what we've done in auth before in Mod 2. Some will be different. Sound good? Awesome. Let's do the thing. Key questions for today. What's the difference between authorization and authentication again? How did cookie auth work in Rails? And why can't I use that with React? What in the ass is a token, and why would I want to put one in my API? Fun skit. What's the difference between encryption and signing, and why should I care? How do I make a token in Ruby? How can the Ruby-JWT gem help? Why is it dangerous to put some information on GitHub? How can .env-rails help? How can I handle validations with register/login on a JSON API? How can I use token auth to secure a Rails API? How TF does has secure password work again? What is the authorization header for? And how can I get a JWT token in there? And finally, how can I use authenticate or request with HTTP token to clean up my application controller? We might not even get to that one. Abdul.
What's going to be the difference between JWT gem versus deeper gem?
Good question. We'll get there as far as this, I think. But if that doesn't get answered by like right here, let me know and we'll circle back and disambiguate those things. Sound good? Cool. I want to start with the API that we are going to be securing today. Auth, well, actually, let's start there. What's the difference between authorization and authentication again? Raise your hand, please. Authentication. Anyone remember? Yeah, Alex.
Authorization, well, yeah, authorization is, are you authorized to access this page or this information? And authentication, are you who you say you are?
Bingo. Authentication has the word authentic in it. Are you authentically who you say you are? You claim to be this person, but I need some proof. I'm not just going to take a username. I need your password to prove that like you're the same person who put that password in 3 months ago, or the same person who requested that stupid password reset email. Are you who you say you are? Authentication. Authorization has the word author in it. Did you create this comment? Can you now delete it? Are you allowed to do the action that you are trying to do? Yeah. We're going to do both of these things. Authorization can't really happen unless we know and trust that you are who you say you are. Currently, I've got an API that does some stuff. It doesn't make any difference who you are when you use this API. Currently. We're here to change that. If I do a get to localhost 3000, nothing will actually happen. But 2 endpoints on this API. One is snacks. What do we got? Yeah, flaming hot Cheetos. But like, what's the shape of this JSON object? What are we generally looking at here? Yeah, an array of objects, which represent, somebody say snacks, please. Snacks! Yeah, we got an array of snacks here. Yeah, flaming hot Cheetos, all these Cheetos, all this stuff. We've also got another endpoint here. users/1. If we were to look for this controller action, what controller would we look in? What method would it probably be called? Oh, Rails. Tom.
Users show.
Users show. Why?
Because that would show you each individual ID.
Yeah, we've got the ID in the URL. We're looking for an individual user, not a list of all the users, but user with the ID of 1. And the cool thing about this API is not only do we get back Dorothy Vaughan, we get her snacks. Dorothy Vaughan has a bag of Flamin' Hot Cheetos, a bag of sour cream and onion Lay's, and a bag of barbecue Lay's. Whereas user 2, Sandy Metz, has a bag of Lay's, sour cream and onion Lay's, and barbecue Lay's. And for that matter, Alan Turing has Lay's, popcorn, and pretzels. Should I do a fourth? Oh yeah, Grace Hopper has all of these. Cool. Individual users have their own snacks, but I've got a list of all the snacks. Now, currently, my API has all of this hanging out on the internet for anyone to see. Ugh, ah. What I'd like to do is change that in the following way. Good. Thank God for history. Ta-da! I've got a PowerPoint. This is where we're going, generally speaking, over the course of all of today. I want a React app with a register page. You can sign up for the app. A login page where you can come back and say, hi, I already signed up, but I need to prove who I still am. I want to do that at this page. I want a snacks page. It's going to list all of that JSON out, but only if you're logged in. And finally, a My Snacks page that will show you the snacks that belong to me, but only my snacks, not yours. I can't see Grace Hopper's snacks. Grace Hopper can't see my snacks. Grace Hopper can't see Alan Turing's snacks. Never the twain shall meet. This is actually a different endpoint than I created on my Rails API. We're going to build these first two. If we're posting to /users, what are we doing, restfully speaking? I'll send the slides out too. Yeah, creating what? Yes, we are creating a user in that case. If we're doing a post to /sessions, what are we creating there? Alex? Yeah, a session, which we're going to use a token to authenticate. Yeah, I might actually pick a different URL for this because I don't want to confuse the Rails session, which works based on cookies, and the session that we're creating with this token. We can even do like /tokens. That might be a better one. And then we'll have a get to /snacks, which we already saw, gives us a list of snacks, and a get to the user's snacks. You should only be able to see if your user ID that you're logged in as is equal to the one in the URL. Cool. We're going to do one thing to this batch of endpoints, both on the React side and on the Rails side, and another thing to this batch of stuff. One of these is going to be authorization. One of them is going to be authentication. My question to you is which one is which? So anyone take a stab at it?
Yeah, I think the My Snacks would be authorization.
My snacks would be authorization. Why?
Because that's it's showing you that page based on knowing that it's you what belongs to you. It's like
Yeah.
you are who you say you are.
Not only do you have to be logged in, you have to be logged in as the user whose snacks these are. Whereas here, we just need to be authenticated. That's not parallel, but yeah, I think I agree. And the great news is my next slide does too. Up top, we gotta be authenticated. For my snacks, we have to be authorized to view those snacks. Cool? Back in our Ruby days of Mod 2, so long ago, we would have done this via cookies. When we made a request to /register, it would be like a form, and we would send a username and password back and get a cookie that would mean, all right, cool, you're now logged in as the user you just created. Back in Rails days, if we made a request to /login, we'd see a form to create a new session with that same username and password field, but this time we'd go and check to see if you'd already created an account, if your password was right, and all of that. And if you did all that correctly, you would get a cookie. Not a literal cookie, but like a browser cookie that would be your token of authentication. Different kind of token than we're going to use in a second. Snacks. If you bring a cookie to the table, you can see the snacks. If you bring a cookie to the table, you can see the snacks associated with the user whose user ID is inside of that cookie. Yeah? And we encrypted that with the session because security, right? I got bad news. You can do cookies in Fetch. You can. You have to do like a little extra fancy footwork in that object that you set up the headers and the body and the method in. You can do cookies in Fetch. You cannot do cookies with native apps. At least not easily. Native apps, if they're going to use the same API as your Rails front end, are going to need a different way of authentication. Authentication as a concern is bigger than just cookies used for authentication. We're going to do a different way. We're going to use JWT tokens. This is going to look a little bit similar. Find and replace the word cookie with the word token. We're going to get more specific about what that token looks like in just a second. But when we build our API, when we create a user, the API is going to give back a token. If you have that token, you can get into the API. If you don't have a token, you can't. When you go to get your snacks, you're going to bring your token over. You're going to say, cool, here are the snacks, or I don't know what that token is, and I don't think it, and you can't come in. If we bring the token in and we try and look at a specific user's snacks, that token will either allow me to see that user's snacks, or maybe Grace Hopper is trying to look at Alan Turing's. The token tells the API that I am Grace Hopper and not Alan Turing, and only has the authorization to look at Grace's snacks. Cool with that in concept? As a reminder, we're only building that stuff that's not grayed out for today. This is the cool thing. We can build an API that works like this, and a completely different person can build the front end. Eric and I had a little conference about requirements this morning. We'll see how it goes. All right. Questions about any of that? Cool. We've reached the point where we need to talk about what in the ass a token is and why I would want to put one in the API. And I'm realizing that I have all of this stuff I set up to get the rooms clear that. Okay. For this particular exercise, I'm going to need 3 volunteers. Hannah is only 1 person. Tom, Alex, please give your volunteers a big round of applause. They not only bravely volunteered, but I didn't even tell them what they have to do yet. It is too late to bail, by the way. Randy and Nikki, do you want to also come up? So Randy and I are going to be the API in this skit. No, not yet. Sorry. Thank you. We have not rehearsed this at all. No. So any of this that goes wrong is completely my fault. What I'd like to do, we're together going to be different endpoints of this API. Specifically, I'm going to be the user snacks endpoint of the API, and Randy is going to be the endpoint that gives out tokens. So those tokens are going to be symbolized by whiteboards. Very important, don't show anyone else your token. Because tokens are private, right? This is the whole thing that lets you into the API. to get the snacks. You don't want other people to be able to steal your snacks. Yeah? Cool. All right. So, if you wouldn't mind, go for it. Yeah, I've got snacks right here. That's my endpoint. I'm sorry, you don't have a token. Our API is authenticated. But there is another endpoint that you might want to try. I told you it was a dumb sketch. No. Any of the other volunteers want to? Where's your token? Thank you for that. Status code 200. All right.
Here and
Okay.
all right.
Okay. No. All right, so this API does not treat all of its users in exactly the same way. Not only is this API authorized, it is a bit authenticated. Different users have different permissions in this API. Some users get big bags of chips, some users get small bags of chips. And I want to talk about how that works on an API level. For this, I actually do want you to show your tokens to the audience. Not you, Nikki, but everyone else. So a token is a chunk of JSON, in this case, which is actually going to be true as we go forward. It's a chunk of JSON with 2 keys on it. What do you notice about your JSON? Or audience, what do you notice about the JSON? Yeah, it has a user ID. And I think all the user IDs are different, if I did this right. Good. What else do we have? Mm-hmm. Yeah, it's a Boolean that always has a false value. What is the name of that Boolean?
Is TCF.
Yeah. If we wanted to like get a big bag of chips, how do you think we could get a big bag of chips? So what did you do there? You changed your isTCF Boolean value to true. Got it. Yeah, okay, so let's give it a whirl. So, this is a critical problem with just using JSON as our token, right? Yeah, she just hacked me, exactly right. JSON alone is very, very hackable because you can send whatever the fuck JSON you want to your API, and if the API is just like, okay, you're gonna have chips all over the place. JSON alone is not enough. We need some kind of validation that this is JSON that actually came from my API, that it has not been messed with by the users of our API, modified in any way. I think it's okay if all of this data is public, in this case, unlike with a cookie. But we need some way of making sure that it's the right JSON. So, we're going to do something special. Okay. Okay, so I've taken away all your tokens. We're going to do a different authentication strategy this time that will support the authorization that we need to do. It will make sure that the JSON cannot be messed with by hackers. Ready? Let's do it. Who wants to be first? No token, no tips. Can I? Yeah, looks good. Okay. Cool. Oh, right. Can you actually sign like over top of the whole thing? Yeah, like yeah. For the metaphor. Got it. Looks good to me.
Wow.
It's gonna go directly.
You don't have to get that 403 error before you come back. Oh, okay. Got it. All right. Show us your tokens. What's different? This time, I asked Randy to sign the tokens. And I asked him specifically to sign the tokens in such a way that if, for example, someone were to try and mess with their JSON, it would ruin the signature, and I wouldn't recognize it as his signature. This is the part of the metaphor that's like a little bit squishy, because like you could erase around the signature or whatever. But the process is actually called signing. Our tokens are going to be signed by our API. Anyone can read the data in them, but if someone tampers with that data, the signature will be invalid. Like one of those like sealing wax seals on a letter or something like that. If you open the letter, if you mess with the contents, the seal is broken, and we'll know. This way, we can have some data about our users. The claims that the users are making about themselves are validated by our signature, the signature that came from our API. Even though our API endpoints aren't directly talking to each other in this case, we have some validation that this JSON actually came from us. Sound good? Cool. All right. I have more snacks also, so and enjoy. And give our volunteers a big round of applause. Thank you all. All right. As you sink into your salt and fat comas, I want to talk about the difference between encryption and signing and why I should care. Before, when we were working with cookies, we also had the problem with people like messing with the contents of those cookies. And we solved that by just encrypting all of the data inside the cookie. So no one could actually see what that data was. No one could mess with it. Encryption is like a safe. You put the data in the safe, you close it, you lock it, you keep the key. You give the safe to someone else, you're the only one who can open it and see that information. Signing is different. The information is public, but it's validated to not have been messed with. In this case, we're going to use signing. In this authorization, we're going to use signed JWT tokens, JSON Web Tokens. I'm at JWT.io, and this is an example of a JWT token in 3 colors. There are 3 parts: a header, a payload, which is the data inside of the token, that's the stuff that's written on the whiteboard, and then the signature. This is like a checksum of the data that's in there. And this has to match what the data was, or it's an invalid token. Cool? So here's the payload. I can actually change this and make it like user ID 7 is TC false. All right, so here our website has just generated one of these tokens. There's nothing encrypted about this token. It is encoded into this format that like humans can't read super well. But if I go over to JWT.io in an incognito tab and I like put the encoded token in here, it'll decode it just fine. User ID 7 is TCF false. It's not remembering between those two tabs what the data is. It's actually encoding that data and decoding it in a format that everyone knows.
So essentially, like if somebody knew the JWT token, they could just go to the site and decode it, and they'll see exactly what it was.
Yes, but if I try and mess with the data in it, even a little bit, I think it'll break. Yeah, see this red right here? The signature is now invalid. This is me trying to make myself a TCF. Not very well, mind you, I just changed it J to a K. But if that data changes at all, the signature becomes invalid and JWT refuses to even. Cool?
What if you decode it and then change the data on and decode it?
So the signature has to come from the API.
Yeah.
If I go here, it's going to give one specific signature. That's like Gracie's signature. In this case, I'm looking for Randy's signature, and if I see anyone else's signature, I'm going to be like, no, fuck you, no snacks. Does that make sense? We're going to do some work on our API's end to make sure that our signature is unique and no one knows how to make signatures as us. But different signatures are different ways. With me so far? Yeah, Abdul.
The process of checking to see if the data coming back has the right signature and is structured as the API does.
Correct. The API both has the power to sign the tokens and also to validate that the signature means that it came from the API. The data came from that same signature. Yeah. All right. Should we do this in some Ruby? Cool. I'm going to need a gem. I'm going to need the Ruby JWT gem, which I think I might still have installed. No, don't. Actually, let's do this. Bundle add Ruby JWT. And while we think about that for a minute, let's go to the GitHub page. Uh-oh. I might be hosed here. Could not find gem Ruby JWT in any of the gem sources linked in your gem file. Okay. Cool, let's try that. Oh, I see. Gem install JWT. Woo! Yeah, no, the project's called Ruby-JWT, but the gem is called something different. This is what happens when you do a lecture for the first time in a year. All right, Rails, C it up. Let's take a look at this line of code right here. What does it look like is going on? Let's go basically just down the right here. Can someone walk me through what they think is going on, at least? And or ask any questions about it that come up. Alex.
From top to let's go to.
Yeah.
First we're requiring our gem.
Mm-hmm.
And then our payload is a hash.
Mm-hmm.
The data is text.
Mm-hmm.
And then here we have our token. We're actually using the job that we require it.
Mhm.
So jot.encode, I guess, is one of the methods.
Mhm.
And you pass it the payload, nil as the password parameter, and none.
Mhm.
And then we're requesting the token that we received.
Yep. Nil is going to be the password that helps us sign the token. It's going to be a secret that only our API knows, that is going to allow us to encode the token in a specific way that no one else can, and also decode it, validating that the same signature that we created it with is the one that we're decoding it with. Yeah? The whole premise of this rests on that password being private and unique. No one else can have access to it, just like a password for your online banking app. Anyone with that password can log in and see your bank account. But worse, with this password, anyone can create valid signed tokens for anywhere in your app. Yikes. We'll talk about how to secure that in a little bit. And this is the token. This is what it actually looks like. Let's give this a whirl. One thing that's confusing about this example maybe is that there are no parentheses on the method call. That is okay with Ruby, but I'll add them in just for convenience's sake. That's my super secure password. Let's throw a payload in here. It'll be a hash. User ID is 42 and his TCF is false. Cool. There's our token. This is what we're going to send back when a user registers or logs into our site. The user is going to hang on to this token and bring it back when they want to see the snacks or see all the snacks or see their own snacks. And when they do, we're going to take this token and run it through this part of the code. Can someone walk me through this line of code to the best of their ability? Ooh, scary one? Yeah, Avi.
When you have a payload, when you're part of the you have a payload that you
Mm-hmm.
you're decoding the file, the password that you gave it. And what you're doing, like, decoded by founders and
Yeah, I'm taking the encoded token, the string that I got from right here. I do need the password, but I think I cleared out of my system. Well, this is a good opportunity to show you what will happen if I try and decode it without the correct password. I get a big, nice error. Oh, that's a different error. Undefined length. What?
There's a period.
Yeah, there sure is. I don't know why that would cause an issue, but let's just try and add some parentheses and see if that works. Oh, good. What? Wait. That shouldn't work.
Did you randomly put the same password you did before on the thing?
No. That's what bothers me here. Okay. So, the reason this didn't work is that I didn't read the fucking manual. Let's take a quick look at this header right here. Can someone just read it to me? None. Yeah, and the little bullet point under it. Yeah. This is how we do a JWT token that is not signed at all. This is our first example in the snacks paradigm, where anyone can impersonate a TCF and tokens are all good with us. The other thing you can notice about this token that I was kind of wondering about earlier is there are only 2 dots in it. There are 3 parts, the headers, the payload, and then the signature. This token doesn't have a signature. We didn't actually do the password encoding thing that I said we were going to do. So let's scroll down a little and do this right. Cool. All right. Crap. I forget which one of those we want to do. Which one of these we want to do. HMAC, RSA? What? Oh,
That sounds right.
yeah, okay. But like which one? They're both here. Let's do HMAC, okay. All right, so let's encode this payload one more time. Let's do this. I'm gonna make a password variable that's equal to the super secret password, and let's do this. So it equals jwt.encode payload user ID 5 HMAC secret. We're going to replace with the super secret password we were expecting. I think this is a parenthesis issue. Thanks, Ruby, for being inconsistent about needing parentheses. And we're good. That's a token, and it's got a signature on it. I think we're already in better shape. Now let's decode. JWT.decode. Slap this token in here. We'll use our same variable password for HMAC secret. And I think all we need here is a parenthesis. All right. We've successfully encoded and decoded the token. I want to show you what happens if we have a mismatch between the password we use to encode and the password we use to decode. This could happen in a situation where the token was encoded by like Gracie, and we're expecting tokens that were encoded by Randy. That is an error. That is the error we actually want. That's the error where someone's like tried to erase around the signature or like just completely sign some other piece of JSON and get snacks with it. This means that someone's trying to hack us. And JWT will fail the verification and not let them hack. If we see an error like this, we shouldn't let the user in. Cool? Questions?
What do you like? How do you respond to this error?
Great question. I think what we'll do is send a 403 unauthorized status code and just not let them see the snacks. I don't think we need to be all that nice user experience-wise to the hackers who are trying to get in. You know, this will be fine.
Well, like we can check to see if like this error was raised.
Yeah, we'll use maybe a try catch or a yeah, something like that. All right, questions about this? Let's take a quick break before we dive into code then, and see you in a bit. All right, let's dive back in. Let's talk a little bit about this user model that I've built for myself. Who wants to walk us through lines 3 and 4? Yeah, got a user snack class, belongs to a user and belongs to a snack, and
also has many snacks.
Yeah, through the user snacks. We've got a snack class. I forget what that was for. Oh, realization, sure. This is like a type of snack. Flamin' Hot Cheetos is one of these. Multiple people can both have bags of Flamin' Hot Cheetos, and they're both like connected to the same type of snack. So we need 3 models here to encapsulate all those things. All right, what about line 6? Yes, what does that do? Do you remember from Mod 2, Avi? Yeah. It's a method that we get from bcrypt that does 2 things to our user class. It gets us a setter for password and a class method called authenticate. You can, no, wait, it's an instance method. Sorry. User. If you've got a user, you can pass in a password It'll do all the bcrypt stuff to verify whether the password you passed in is the same as the bcrypt password that we hashed when we set up that user through the setter for password. Because I've got has secure password in here, it'll look at my schema, look at the password digest column in my users table, set that when we create a new one, as long as we pass that password in, and give us the power to validate that a password that a user is coming back with to log in can be validated. We're going to use hashing and passwords to figure out if the user is who they say they are. But we're going to use tokens so that they don't have to log in every time. Once you log in with the correct password, you get the token. That's your proof that you did log in at one point. Tokens can like expire and do all kinds of other stuff. We're not going to focus on that today. But users are going to have passwords. We also have a wee little validation on line 8. What will this do?
Validate that there is the username.
Yeah, and if there is no username, what will happen? Bobby. You'd essentially be logged out. I would actually tweak that to you won't be able to log in the first place. You won't be able to register in the first place. That user, when we save it in the registration process, will not be allowed by active record to hit the database at all. We're going to do a little bit of validation logic to make sure that this user can't be created with no username at all. Cool? All right, let's do the thing. So in our user's controller, I've got a create action already. And it currently does nothing more interesting than completely exploding, actually. Let's give myself a route for that user and try this again. Beautiful. Empty JSON object. So, as we're, oh, yeah, that's a good question. Am I? Yes. What do I want to do in this action? Does someone want to drive for a second? It's going to be pretty similar to what we do in Rails.
User equals user. Dot.
Oh, yeah. Dot.
I want to say dot new,
Cool.
and then
Well, I'll just do the strong params. Private. We don't want to let users like set their hash password directly. That would be kind of a disaster. God, it's been so long since I've done Ruby. What? Help. And params dot require user permit we want to allow the user to create themselves with a username and a password. Nothing else. Not a password digest, not an is admin true or false, not an is TCF true or false. That's up to us to decide, or maybe a different admin user. Those are the only two params we want to create. What's next? Yeah.
valid.
Yeah, let's validate. Let's say if user.save, save returns true or false based on whether validations passed and we got saved, or false if they didn't pass and we didn't get saved. If user.save, I'm just going to do this for now. Worked true. Else. Oh no, param is missing or the value is empty user. All right. This is happening because we're not actually sending any body over in our request. Give me a second to, oh, here's the body. Great. Let's make sure we're sending the correct headers. Content type application JSON, good. In our front end, we'll be doing this with a fetch. This will be the body to our fetch when we want to register and create a user. We'll probably get those values from a form on the front end. For now, I just want to test it with this JSON object. Perhaps missing the value is empty user again. Okay, I don't know why that's happening, frankly. Yeah. Where?
No, yeah, I think
You're expecting a nested hash of user.
I am, and usually it does that for me. Oh shit, I'm a stick. Hold on. No, I'm good. Avi, what are you thinking? Yeah, let's try that. That seems to be a consensus. All right, that's better. Worked false is what we got.
because you didn't put username.
Oh, yeah, all right. Whoa, awesome. So we do have a test of our validation indirectly. Let me do a better one. Username is empty string, presence false. Username is Graham, worked true. Our validations are working as we had hoped. I'd like to actually extend this a little bit and say, all right, if it doesn't work, let's send back an array of full messages to say why. Let's send back those validation messages. Just tell someone, hey, you know what, username can't be blank, specifically. And if it works, if we do create a new user, what do we want to send back then? Say that louder. The token. Yeah. We want to send back a valid token so that user can then come back and see their stats, for example. Where's that line of code that I had in my IRB? I did clear it, didn't I? That was silly. All right. What do I want to put in the payload of my token? Will be a handy thing to stick in there, Alex. Yeah. Let's do this. User ID equals user.id. We're going to need this password to be something. I'm just going to hard code it right here for now. And I'm just going to send back the username as well, so that we could maybe display that in the UI. Yeah.
Are you trying to save this user to the database?
Yes, and that happens right here.
Shouldn't that be create? Oh, that happens there?
Yeah. Create is just a new one to save. I could also do user.create and a user.valid, valid, and it'll work the same way. Fix one, half dozen of the other. Cool? So the cool thing is if I come at this with a valid user, I get a beautiful internal server error. Initialize constant users controller JWT. Oh, okay. I think this is because I added that gem and I didn't restart my Rails server, which if you ever add a gem, you should really do. Let's try it again. Just to prove to you that this token is readable by everyone, I'm going to go back to JWT.io, type it in here, encoded token. This token didn't even come from this website, and still I can see that I am user ID 9. I saved a lot of users in there apparently. Whoops. I don't think I have a uniqueness validation on the username either, which is going to be really terrible once we get to login, but whatever. Yeah, this data is public for the entire universe to see. As long as they can decode a JWT token, they're in good shape. Questions?
It's already coded in that token.
It's signed. So people can't mess with it. That user ID can never be someone else's user ID. I can't just like decrement that and be like, hey, I'm user ID 7, because I can't get a signed token with user ID 7. I can only get the token with the user ID that I actually signed up with. We have it's public, but it's not mutable. It's not changeable. Yeah.
Can you encrypt that stuff so even if it's public, it's like, you can't do anything with it?
So we already can't, the user already can't do anything with it. If we want them to not read it, we would have to encrypt it, yes. In this case, I don't really care if anyone knows that they're user ID 9, as long as they don't lie and pretend they're user ID 8. That's the way JWT works. Different than the cookie, different than the session in Rails. All right, two things we could do. One, talk about how to secure this password so that when I like push this to GitHub, no one knows that my password is this for the JWT token. Again, would be really bad. Anyone could generate lies about which user they are based on seeing my code in my repo. Or, and I'm sort of leaning toward this idea, should we do login? Do we care? Are we dead in the water here? Did I go too fast? All right. How are the Cheetos sitting? Good? Anyone got a stomachache? All right. Actually, better yet, let's not do login. Let's go to our snacks controller and make it so that only when I come to my snacks controller with a valid token, I can see the snacks. Sound good? Great. I've got this token back from my API. You could say that with this token, I'm logged in. This is a valid way of accessing the API. And I want to tell anyone who doesn't have a valid token to zark off. This controller going to be authorized or authenticated? Or both? Both? Tell me why.
It gets authenticated through the token, and it's going to be authorized in here if you do some authorization.
So only specific users can see the snacks?
Right, yeah, right?
Got it. Which ones? Just TCFs?
The ones that are authenticated?
Yes.
Okay.
So it sounds like it's maybe just authenticated, not authorized.
Yeah, no, it's not authorized. Sorry, I didn't. Okay. But you authorize it here, right? That's where you authorize.
We're actually just going to do authentication here. We're going to say if you're logged in at all, you can see all the snacks. If you're not logged in, fuck off.
Okay.
Let's be specific about fuck off first, since we're there. Anyone seen the meme with the drones where it's like, if going to crash into each other, don't? We're basically going to do that. Oh, God. I forget how to do this. Does Rails come with a not authorized exception? Not what I wanted. Still not what I wanted. Everything okay? Sweet. This I think I can use. I want to make this a JSON object. And this will give us a status of unauthorized if we don't have a token, which remains for us to implement an authenticated method. And I'm just going to say false. I want to test this part of my authentication first. I want to test a get to/snacks with no token at all. All good? What should I get back from the API currently, based on the way this code is written? Yeah. Line 8 should get hit, and I should get back this JSON payload with the status of unauthorized. Beautiful. 401 unauthorized is our status code. Wasn't a 403 at all. I said that wrong multiple times. But we've got authentication working in our API, sort of. What this method needs to do is actually check to see if that token is there and if it's valid. We need to check two things. One, did this user have a valid token? Did the user supply a token at all? So I want to dive into that. And I want to test this first with a valid token. When we had a cookie in Rails, where was that cookie sent in the request? That's a rough question, yeah. Body is not actually where it is in this case. You could actually send it in the body if you wanted to. No, cookie's somewhere else. Abby. The header, yeah, there's a header for cookies. Beyond this content type application JSON header, which we don't really need for this actually at all, there is a cookie header that is called cookie. And you can shove stuff in it. We're not going to use that. We're going to use a header called authorization. And we're going to stuff our token in there instead. Cool? This is what the header is for. All right, currently we're not checking that header at all. But I'm about to change that. Nope, wrong controller. Hold on. Do it. All right. So here we are in our authenticated method. Let's take a look at this request. Ooh, so much stuff. This request does not really have a body, empty string. Ooh, whoa, look at all the headers. Good Christ. Ta-da. What's that? Token, yeah. So let's say if the token is there, then we might want to do this. Else we'll just return false. Yeah? If the token is there, then we're on the right track. If it's like an empty string or not there, then we'll return false. $500. Okay. So if I check off this header, go away true. If I check it on, I hit my buy bug. We also need to validate that this token is a valid one. It's not just enough to have any text inside that authorization header. We need to make sure that this is a token that is valid and one that we signed. How are we going to do that? Abby. Yeah, let's decode it. All right, here's where our example code is going to come in real handy. Let's do this. Decoded token equals JWT.decode token. We're going to need the same secret that we had over here in the user's controller. I'm just going to copy and paste for now, and then we'll refactor to hiding that somewhere. This should be good. Maybe. I don't know. Let's find out. Let's just cancel that request entirely. Send. Oh, goodness. Let's try that again. There we go. We have a valid decoded token in this case. Because we encoded and decoded with the same secret and all that, we've got a valid one. What will happen if I Cancel this request, exit this bug. No, really though. And like mess with the payload. I've eliminated one vitally important character in my authorization header, which contains one of these beautiful tokens that were earlier represented by a whiteboard. I messed with my authorization token. What is JWT going to do about that? It's actually going to do something even more dramatic. Oh no. What do we get?
Verification error.
Yeah, we got a giant verification error. The whole thing like came down like a house of cards. We didn't just return false. We stopped the entire execution of the application, which effectively prevents someone coming in with an invalid token, but it's sort of like burning the house down when there's a spider in it. It's a little more than I actually wanted to do today. So let's do this. Let's do... So we done a try catch before?
Yeah.
Basically, what this does is, if we expect this thing right here on line 19 to maybe raise an error, we can rescue a specific type of error. I don't know. I don't even know if that line of code is ever going to get hit, but that'll be fine. So if we get a verification error, we want to return false from this method. Not authenticated. I don't think this is actually necessary because decoded token had better be a thing, but it shouldn't hurt. If we experience an error here, this line of code gets hit. Otherwise, we'll keep going. Cool? Let's give it a whirl. We return false, go away is true. Unless we have a valid token, in which case we see the snacks. I think we can just return true there. I think that's probably fine. Does it still work the same way? Yeah. And then if we mess with this token a little bit, still go away true. Yeah, I'm happy with that. Questions?
Sorry, could you kind of walk through that
Sure.
method once more?
Can you actually walk me through it and I'll chime in when needed? Sorry.
All right, so we're setting our tokens equal to the request headers.
Yeah, the authorization header in the hash that Rails gives us of all the headers that were provided from the client on this request. This header will be whatever I have from the client right here. Whether that's nothing, not enough for too many segments. Yikes. If token. Oh. JavaScript. I've been doing JavaScript too long. There we go. Yeah, if that token is absent, then we'll get this false. I interrupted you. Sorry.
No, that's okay. You answered my question for line 17. I was confused about the token and token.length.
Yeah.
Not length.
Token.length is 0, and in JavaScript 0 is falsy, and Ruby is 3. Try to get too clever. Rails also has a method for this. That should do it. Yeah. Cool. So if the token's present, then we try. If we fail, return false. If we succeed, return true. The end. Okay, we got 10 minutes. Let's do this. I want to do some authorization as well. I'm going to skip to the users controller And we want to do a method here that means that only if the user is logged in as the same user whose snacks we're trying to show, can we see those snacks. Did that sentence make sense? Not really. I kind of lost track of it. Only if the user is the same user that we're trying to find right here, only if the user's ID inside that token is the same ID as the user we're trying to show the snacks of, can we see those snacks. If you're someone else, go away. I'm going to make a new method called authorized. And I'm actually going to do this. User ID equals params ID. So we only bother going to the database if that person's authorized. Cool. Make it a little faster for people to fail. All right, now my only job is to write this authorized method. Ready? I'm going to shift gears a little bit at risk of losing you further and stick this in the application controller. You okay with this? Stay with me, 10 more minutes. And what I'm also going to do is I'm going to grab out of my snacks controller this. We can still access it here if it's in the application controller, but we're going to want some of this code in order to figure out what the user ID is. We're going to have to do a little bit of refactoring to see if there is a valid JWT token or not. Cool. All right. I'm going to create a method that's going to be private, that's going to be try get JWT token. I want it to either return a valid JWT token payload if there is one, or nil if not. That way, authenticated and just return true if try get JWT token does return something, and false if it doesn't. And authorized can actually do the comparison between that user ID inside the payload and the one that we passed in. Are you with me? All right. Still want the token. I still want all of this. The only thing that really needs to change here is what we return. We don't want to just return true if we've got a decoded token. We want to return the actual payload in that decoded token. I want to show you what that payload looks like, because it's not actually what you might suspect. Right here, we're about to return that decoded token. What would it make sense for this decoded token to look like from a Ruby perspective? Like what data type, what shape should it have? Would you imagine it might have? Adi? A hash, yeah. With what keys in it? Yeah, that'd be really nice. It would be really nice if it was like the same payload that way back, when we actually encoded this token. It would be nice if it was this hash again. Yeah? Pero no lo es. It's an array. I don't know why it's an array. They made it an array. We got to deal with that array. The first element in that array is always going to be the thing we're looking for. The element with the user, the hash with the user ID key in it and the value of 9. So I can make this work. Ruby's nice. Yeah, that's a little better. Yeah? Cool. And then this can just be try get JWT. if token dot present. Actually, let's do this. Return token dot. Go with this. If the token is present and the token's user ID matches the user ID we passed in, we return true. Either of those things are not true, false. Let's give it a whirl. As we can see, we're user ID 9. So let's go and try and look at user 9 snacks. Oh no, what? Shit. Try and look at user 8 snacks. Still not. Do I have a bad token? What's that?
Did you change something?
Change the token?
Did you change like the
Maybe. Let's try and get a new one. Post to users, JSON, username. But it's not. Oh. Yeah, there's a token. Okay, I actually do have a bug in my code, this looks like. Let's do this. Ah, I love this bug. What happened?
Like user ID of different types.
Yeah. My fucking type coercion. All right, let's do this. User ID to I. I'll cancel that. Cancel that. Canceled. You're canceled. Perhaps I spoke too soon. The fuck? Oh, right, okay. Cool. Oh shit, I think the token has string keys too. Yeah, okay, so token dot present is true. Oh, what? Oh, because okay, let's continue. Fuck me. All right. Move the bybug down one line. And do it again. There you are. Yep, that's nil, because it has to be a bloody string. There we go. Drum roll, please, and pray for me that this is true. I'm rooting for you, potato. Oh, fine. Yeah, do the bybug. Ah, there are my snacks. I don't have any. That's the bad news. The good news is that I'm the only one who knows. And if I try and go to Grace Hopper snacks, or like, I guess that was Graham snacks, I gotta go away, true. So, some conclusions here. Auth is a little hard. There's a lot of logic in here, and there's a lot of debugging that needs to happen. I rushed through a lot of that. It's good for you to do that debugging in your own time. We have very limited time to go over auth, and I wanted to show you some of the beats of it. I wanted to show you authorization and authentication, which I've barely pulled off. Yes, for the love of God, save those changes. We've got an authenticated index on our snacks controller. We've got an authorized show page on our users controller. So we can only see the user profile if we are the same user, whose user profile that is. The only thing that we didn't get to is how to log back in. I'll work that out over lunch. Eric will have that to play with in the afternoon. If you're curious, the flow is going to look a little bit like this. I might refactor a couple of these other things. Oh, and the most important thing I missed is this. Don't put this in GitHub. I'm not going to. I'm going to use a gem called .endrails to put that into a file that will never ever get put into GitHub. If we're on a development team and we all need to use the same signing key for our website, we'll have to like pass that around on sticky notes or something like that. We'll have to like find some secure way besides GitHub of sharing that. Why do we want to put that in GitHub, Graham? Well, okay. I don't have an example for you specifically with regard to auth, but basically what would happen is anyone can sign Randy's name and get the snacks. Oh yeah, I do have 38 tabs open. The class before was asking about that. I'm going to show you a blog post that one of my students made. She went to Flatiron School on the Manhattan campus. She did a really cool project with AWS and got a key for AWS for the API. You have to put in a credit card for AWS because they do charge for some of their services beyond a certain point. And she checked it into GitHub, which is not an uncommon mistake. It is a huge mistake, don't get me wrong, but it's not uncommon. And as you're probably already reading, someone found her AWS token on the public GitHub and used it to buy a bunch of AWS services to the tune of $3,000? Oh, $7,000 in the end. I still don't know if she actually got all that money back, but there are certain things you don't want to put on GitHub. There are people out there on GitHub trolling GitHub for stuff like this that will give you access to stuff that you shouldn't have. We're going to figure this out pretty quickly because, you know, your credit card was linked up to it. If you put the encryption key for your token on GitHub, the worst part about it is you'll never know. People can use that to create tokens that are invalid. It'll be really, really hard to detect if someone is breaking your authentication completely. So I'm not going to show you right. Actually, I will show you right now if you want to stick around how to secure this API because it is important enough. But if your hunger is calling you, look at the code after lunch. That's okay too. Thank you all. Oh, right. I forgot about that. Okay. Here's how we're going to do it. You go ahead and leave if you want to. We're going to use a gem called .endrails, which I have now forgotten how to use. Bundle add .endrails. The way .endrails works is it adds specific key value pairs to your environment variables. Usually environment variables are just things that are passed in by your operating system when Rails starts up. In this case, we're gonna like add a couple, specifically for the stuff that we don't want to commit to GitHub. So I've added .endrails. I can Rails S myself again. And what I want to do is stick this string right here into my into my environment variables. I'm going to do that by creating a very specific file. I lied. I do actually remember how to do this, but it's very well documented on GitHub if you want to learn. I'm going to create a file called .env. This is the secret file that I'm never going to check into GitHub. I'm going to make sure that I can't check it into GitHub in a minute, but this is my file full of secrets. Yes, just do it. Key value pair. Key name is JWT secret key, =, and then the value. Cool? Then, on the other side, instead of a string literal, you use all caps env and the same string name. The only thing then that gets checked into GitHub is the name of this value. The actual value of the value is secret and just on my computer. And the cool thing about it is I can de-hard code it from like here in the user's controller, and then also I think it was in the snacks controller. No, it was in the author. Fumble, fumble. Fumble some more. There it is. Everywhere that JWT secret key needs to be, it can just come out of the env there. Cool so far? Okay. For my next trick, I'm going to hide the .env file from GitHub. Currently, I've got all of this code here. If I did something like git add dot, I would add my gem file, my readme, all of these app controllers, models, routes, and the tokens controller and the tokens controller test. But also, this file that is in completely the wrong place. This needs to be in the root of my Rails app. Hold. Yeah, it should be right there. But more importantly, I could very easily accidentally commit this. It would be pretty hard to remember not to commit this, honestly. The more times you commit, the more people need to commit to this repo, the harder it's going to be to remember not to commit this file. I would rather that there was a programmatic way to ignore, certain files in GitHub entirely. That's gone. To GitHub, it doesn't even exist. Done. Oh, I should check and see if it still works, eh? No one does a conversion of nil into string. Oh, fuck. Try get JWT token. I don't know, let's try restarting Rails. Good. I love it when that works. Go away is true in this case, but I can still get back to my snacks if I need to. And what's better? No one's going to steal my keys. Cool? All right, I'll do login. You can take a look when you get a chance. Thank you all.